The number of real roots of the equation 5 plus modulus of 2 to the power x minus 1 equals to 2x minus 2. So what we are given is 5 plus modulus of 2 to the power x minus 1 equals to 2x minus 2. So I can see that modulus of 2x minus 1 is given. So I am taking case 1 as if 2x is greater than or equals to 1. In this situation, we will get 5 plus 2 to the power x minus 1 equals to 2 to the power x minus 2. Let 2 to the power x equals to t. So we will get 5 plus t minus 1 equals to t minus 2. Solving this, we will get a quadratic equation. It will look like t square minus 3t minus 4 equals to 0. Now the solutions of this quadratic equation will be t equals to 4 comma minus 1. Now 2 to the power x cannot be negative. So we are getting t equals to 4, which means 2 to the power x equals to 4 and x equals to 2. This is the solution we are getting from case 1. Now we will do case 2. Case 2 will be if 2 to the power x is less than 1. In this case, what we will get is 5 plus 1 minus 2 to the power x equals to 2 to the power x minus 2. Here also I am taking net 2 to the power x equals to t. So we are getting 5 plus 1 minus t equals to t minus 2. From here I am getting another quadratic equation, t square minus t minus 6 equals to 0. From here the solutions will be t equals to 3 comma minus 2. Now 2 to the power x is not equals to minus 2. So we are getting 2 to the power x equals to 3. But 2 to the power x equals to 3 is invalid, as we have taken 2 to the power x is less than 1. So from this case we are getting no solution. So finally we are getting only one solution, x equals to 2. Therefore number of real roots of this question will be 1. Option A is the right answer to this question.